In this project, you will learn what interrupts are and how they can be applied to your electronics projects. We will be building a simple circuit that illustrates how we can configure and set up an interrupt which performs an action on our circuit when the appropriate event is triggered. In our project, we will toggle the state of an LED when a button is pressed by using an interrupt. Let's take a look at the objectives for our project. By successfully completing this lesson, we will have mastered the following items. We will gain an understanding of interrupts and why they are useful. We will learn how to set up and configure them in Arduino using the attach interrupt function, and we will define a function that reacts to our interrupt. If you are ready to begin, let's get this project started. Here are the parts we will need: an Arduino Uno, a USB cable, a breadboard, a 1 kilo ohm resistor, a push-button switch, and connecting wires. Let's first discuss what interrupts are. They are very handy for making things happen automatically in a microcontroller circuit. Usually, we spend a lot of time sitting around and polling, waiting for events to happen. This is a waste of processor resources. Interrupts allow us to be notified when an event which is important to us occurs so we can act accordingly. They provide a great way to solve timing issues in projects. Some good use cases for interrupts might be reacting to user input so that we can be notified when a user is trying to get the attention of the microcontroller, for example, pressing a switch or changing an input, giving priority to important processes we care about, and optimizing resources that are wasted just sitting around and polling and waiting for events to happen. Specifically, let us address how interrupts are implemented in Arduino. We normally define ISRs, or interrupt service routines, which are separate functions that we want to fire or execute when an interrupt occurs. These should be as short and fast as possible, and the functions cannot accept parameters or return any values. Only one ISR can run at a time, and if you have multiple in your program, they are executed in the order in which they occur. It is important to note that time functions like millis and delays will not increment or work in interrupt functions, since these themselves rely on interrupts to operate. In order to store information, global variables are usually used to pass information between ISRs and your main program, and these should be identified with the volatile keyword. That was quite a lot of info, but it will become clearer when we delve into some code. Let's take a look at the circuit diagram for our project. It is very straightforward. We have a push-button switch. One end of the switch is connected to ground on the Arduino. The other end of the switch goes to pin 2 on the Arduino, and there is also a 1 kilo ohm resistor from that end of the switch to 5 volts. So we connect that to the 5 volt rail, and then we make our final connection from 5 volts on the Arduino to that 5 volt rail. That's it. Very simple circuit. Let's go ahead and wire up our circuit. First, we'll connect the push button switch. Then, from one end of the switch, we will go to ground on your Arduino. The other end of the switch goes to pin 2 on the Arduino. There's also a resistor to the 5 volt rail from that end of the switch. And finally, I'll go from 5 volts on the Arduino to the 5 volt rail. That completes our wiring. Alright, let's go ahead and upload the code. Right, when that's done, let's go ahead and open the serial monitor. So now, we're going to test our circuit out. When I push the button, the built-in LED should light, and we should see an interrupt fire on our serial monitor. So there you see it. I pressed it once, and the interrupt, you see the interrupt occurred, and the button lights, and now if I press it again, another interrupt occurred, and the LED is toggled. So as I keep pressing this push button, the LED will come on, and when I press it again, it will come off. And what's happening is actually interrupts are occurring and are being handled to toggle the state of the LED to on and off. Now you may notice that when you press it, you may get several interrupts occurring, and as you can imagine, that's happening because of the bouncing. So when I actually press the button, it's making contact several times. So that's why several interrupts may fire, and you may experience this when you actually run this project yourself. But nevertheless, the project is meant to demonstrate how interrupts occur and how they can be handled. So hopefully you get the idea. Let's take a look at our code. So initially, we do a constant int for our LED pin, setting that to 13. This is another way of doing define. We're just defining an integer. We're setting it to a constant, meaning that cannot be changed, or the value of this LED pin variable cannot be changed anywhere later on in our program. So our LED pin is 13, that's the built-in LED. Then we do the input pin, which is connected from the button to pin 2 on the Arduino. In our setup function, we set the pin mode of the LED pin to be an output because we want to write to it to toggle the LED. And we also enable the input pull-up resistor on our input pin just to set that high in the state when the button is not being pressed. And here is the syntax for attaching our interrupt. So we do attach interrupt. The first argument is either a 0 or a 1, and we'll look at the documentation shortly, which will clarify what that means. We then pass in the actual ISR, or interrupt service routine, that we want to run, which is a function, and we pass in when we want that interrupt to occur. So here we're specifying on the falling, if the signal falls from high to low, that's when we want our interrupt to fire. In this particular program for loop, we actually don't do anything, so there's no logic in here. And here is our interrupt service routine. It's called button pressed, which is specified above. And remember, for an ISR, it cannot take any arguments, nor can it return any values. So it's just a void button pressed. In here, we're gonna write out to the serial monitor that an interrupt occurred. We're going to do a read on that LED pin. So if digital read LED pin, if that's high, we're going to write to that LED pin low. Simply we're toggling the state of it. Else we're going to write to the LED pin high. So once the pin is set high, it's set back to low, and vice versa. It keeps toggling every time we press a button. An interrupt happens because of the voltage going from high to low, and once that interrupt ISR button press function is fired, we toggle the state of our LED. Let's quickly look at the documentation for attach interrupt. I'm going to Google that and open it up. So as you can see on the Arduino Uno board, which is the board we're using, you can attach interrupts on pins 2 and 3. We are using pin 2 in our circuit. Now, in the syntax for the attach interrupt function down here, the first value of this variable, or this argument, is 0 if you had used pin 2, or 1 if you had used pin 3. Alright, so that's why we used 0 when we called the attach interrupt function. You can also use this digital pin to interrupt and pass in the pin number, so you could do digital pin to interrupt and you pass in 2. That will evaluate 0 for you. Alright, so but we just put 0 in there. Next, we have the actual interrupt service routine, or the function we want to execute when an interrupt occurs, and then we can specify the mode. So as you can see here, mode, there are a few different modes. Low can be used to trigger the interrupt whenever the pin goes to a low value. Change, if the value changes, rising or falling. So there are several different configurations here that you can set up for your mode. And that's it. Right, so that's the syntax for our interrupt, or our attach interrupt function. To summarize, in this project, you learned what an interrupt is and why it is important. You also learned how to set up and configure interrupts for your Arduino program using the attach interrupt function. It was a simple project, but demonstrated an important concept that we will use in the game we will build in our next project.